Hello everyone, my name is Chiu Tang, and in this video, I'm going to talk about 12.4, the cross product, which is in chapter 12, vectors and the geometry of space. So now let's get started. So for the content of this presentation, I'm going to talk about three things. The first one is the cross product of two vectors in space. The second one here is just how to calculate cross product. The third one are the three applications of cross product. So now let's get started with the first one. So for the first part is the cross product of two vectors in space. So by definition, if you have two vectors and you cross it, you will receive, example, vector u and vector v, you cross them, you would get a magnitude of u, magnitude of v times sine theta, which theta here is just the angle between vector u and vector v, and n, which is the normal vector, which is the vector that is orthogonal or perpendicular to both vector u and vector v. And unlike the dot product, the cross product gives you a vector, not a scalar. And this vector that is resolved from u cross v is orthogonal to both vector u and vector v. And just like any other vector, u cross v has a magnitude and a direction. And here we'll take a small note about its magnitude. Magnitude of u cross v is magnitude of u times magnitude of v times sine theta. We'll use this later on. So let's move on to the next part, which is what does it look like? So as you know, if you have two vector, vector u and vector v, and you cross it, you would get a vector that is orthogonal to both vector. And if you have the same vector and you use v cross u, instead you receive the same vector that is both orthogonal to u cross u and vector v, except this time it's in the opposite direction. But how do you remember it? Well, one way to remember it is the right hand rule. So I'm going to show you how to use the right hand rule. So for the right hand rule, example, this is the u vector and this blue one is the v vector. So how do you use your right hand rule? So to use the right hand rule, you obviously use the right hand. Just point your forefinger toward u, so u, and then curve it toward v, and your thumb would be pointing toward u cross v. What about v cross u? For v cross u, you would do the same thing. Use the right hand forefinger, point toward v, which is the blue one, curve toward u, and then your thumb would be pointing toward v cross u. So it will look something like this for v cross u. So now let's move on to the next part, which is the parallel vector. So for parallel vector, you have two non-zero vector and its u cross v is equal to 0. That would mean the two vectors are parallel to each other. Now that we have learned the definition about cross product, let's move on to how do you calculate cross product. So you have two vector, vector u and vector v. To cross it, you would use something called the 3x3 determinant. So for the 3x3 determinant, for the first row, you would have I, j, and k. For the second row, you would have the x, y, z component of u, and the third row, you would have the x, y, z component of v. And what to do next? What to do next is you have to convert this to a 2x2 determinant. How to do it? Well, the way to do it is to cross out the first row and the first column to be left with 4 elements. And this 4 elements, you use it to create a 2x2 determinant right here. And a minus sign, and you do the same with j. You cross out the first row and second column, and you'll be left with 4 elements. u1, u3, v1, v3. This can create a 2x2 determinant. And again, for k, you do the same thing. Cross out the first row and the third column. You'll be left with 4 elements, and these 4 elements will be used to create the 2x2 determinant. So now that you have the 2x2 determinant, what next do you do? Well, to solve the 2x2 determinant, you use you use AD minus BC. So you apply this formula to all these three 2x2 determinants, and you receive your final vector, which is this part I minus the y component j plus the z component k. And as you can see, this is a vector, just like what we have talked about. A cross product is will give you a vector. Now that we have learned how to do cross product, let's look at one of three of its application. So the first part is area of parallelogram and the triangle. So if you have this parallelogram, if you have a parallelogram, so how do you calculate area and how is it related to cross product? Well, normally to calculate the area of a parallelogram, you need to know its base and its height, base times height. But the base for this parallelogram is just the magnitude of u. And what about the height? Well, for the height, you have to use trigonometry to help. In our case, we can use sine theta. So sine theta is equal to h over magnitude of v. So h, the height, is equal to magnitude of v times sine theta. Now you have the base and the height. You plug it in, you receive something like this. Well, recall something that from the first slide of from the definition part, I take a note that u cross v, the magnitude of u cross v is equal to magnitude of u times magnitude of v times sine theta. And if you look carefully, this part and this part is the same, which means you can just replace all of this with the magnitude of u cross v, which is what the area of a parallelogram is. It's just the magnitude of u cross v. What about a triangle? Well, for a triangle, if you have a parallelogram like this, to get a triangle, or two in this case, all you have to do is cut it into two, and you'll get two triangles of the same area. And to find area of one of the triangle, all you have to do is divide this formula by 2. So that is the first part of the application. Let's look at the second application, which is torque. So for torque, what is torque? Torque is a force that tends to cause rotation. So if you have a bolt and a wrench, and you apply force onto somewhere on the wrench, you will create torque. And the formula for torque is magnitude of R times magnitude of F times sine theta, where R here is the distance from axis of rotation to the point where you apply the force, and F is the force itself. So magnitude of F is just magnitude of the force. Sine theta, theta is the angle between the F and R. So if you look carefully, this and this formula again is similar to the formula of magnitude of u cross v, which means that you can write torque in expected form as vector torque is equal to vector R cross vector F, which is the cross product. Now let's move on to the third application, volume of parallelepiped. So to find the volume of parallelepiped, you have to know its area of base and its height. Well, you know the area of the base, this area, all of this area down here, you know how to calculate it already from the first application. It's just magnitude of u cross v. So that is the area of base. What about the height? Again, for height, we have to use trigonometry. In this case, we can use cosine theta. So cosine theta is equal to the height over the magnitude of w. So the height is equal to magnitude of w times cosine theta. So you put them all in. But to proceed further, we have to think back to 12.3, the dot product. So in dot product, there's a formula that says u dot v is equal to magnitude of u times magnitude of v times cosine theta. This formula here and this formula here is very similar. All you have to do is replace this u with u cross v and this v with w, which is what this is what I did right here. I place u with u cross v, v with w, and you get something. U cross v dot w. And this u cross v dot w, you can just replace it. You can use this and replace this part, and you get the formula for the volume, which is u cross v dot w. And why is an absolute value? Well, sometimes when you use this formula, you might get negative number, and volume cannot be negative. So there's absolute value to make sure that it is positive. So now that we know the formula how to calculate volume, but like the formula seems a bit complicated. It has a cross product and it has a dot. So how do you calculate this? Well, let's see. So to calculate, for example, if you have vector u, vector v, and vector w, but to calculate u cross v dot w, it's no different from how you calculate u cross v, except that this time you place I, j, and k with w1, w2, and w3. and then you proceed to do the calculation normally, which is what happened here. U cross V dot W, you replace I, J, and K with W1, W2, W3, and you change it to 2 by 2 determinant. You use AD minus BC to create all of this, and the result from all of this will be a constant, will be some number, because it's no longer I, J, and K. We just give you some numbers. Now that we have learned all the 3 applications of the cross product, let's look at one example. So for the example, they ask us to find the area of triangle with vertices A100, B020, C00 minus 1. And if you were to draw it, this is how the triangle would look. And we now have to find the area. Well, you know that the area of triangle is equal 1 over 2 magnitude of U cross V. In this case, U cross V can be, since A, B, C are all vertices, U cross V can be AB cross AC, or BA cross BC, or CB cross CA. But in my case, I'm just going to use AB cross AC. And we do not know what AB or AC is, but we do know what the point A, B, and C is, so we can find vector AB easily. So to find vector AB, we would go 0 minus 1 is minus 1, 2 minus 0, which is 2, 0 minus 0 is 0. And for AC, you do the same thing. For AC, 0 minus 1 is minus 1. 0 minus 0 is 0, minus 1 minus 0 is minus 1. Next, you have to do, well, you have to cross it. So I'm going to cross it, AB cross AC. And you have the 3 by 3 difference is I, J, and K. The second row would be your XYZ component of vector AB, so minus 1, 2, 0. The third row would be the XYZ component of AC, so it's minus 1, 0, minus 1. And now the next, you have to, now we have to calculate AB cross AC. Well, to calculate it, so you cross out the first row, the first column, you will left with this 4. So AD is minus 2, minus 0 times 0, so it's just minus 2. For J, you do the same thing. AD minus BC is minus 1 times minus 1 is 1. And this minus, then minus 1 times 0 is just 0. So it's just 1. So it's minus 1 plus, okay. Do the same thing. So first row, third column, or less, minus 1 times 0 is 0. Minus, minus 1 times 2, which is minus 2, but there's a minus sign. So 2, okay. So this is AB cross AC. But next thing you have to do is find the magnitude. Well, the magnitude of AB cross AC is just its square root. So the square root of x component square, so minus 2 square plus 1 minus 1 square plus 2 square, which is 4, 5 plus 4, so 9, square root of 9, which is 3. So to find the area, you have to divide by 2. So the area of this triangle is 3 over 2. So that is all for this particular exercise, and that is also the end for my presentation. Thank you for watching, and I hope you learned something valuable today. Goodbye.